University, Lahore, and has been a part of the oil and gas industry for the last 13 years. He has worked in Pakistan and the UAE. His expertise is in reservoir engineering, production optimization, and digital production and drilling operations. Currently, he is in the Services Delivery Manager for Digital and Integration, SLB, Pakistan. Each paper will have 15 minutes. After 10 minutes, the bell will ring just to indicate that 5 minutes are remaining. So you may start up and start to close your presentation. And then we will have 5 minutes for question answers. So in total, you have 15 minutes to present and 5 minutes for the question answers. The chair and co-chair shall be monitoring the time. Let's begin with the first paper, Application of Machine Learning for Effective Screening Criteria of Enhanced Oil Recovery Method Implementation with Optimum Accuracy by Jawad Ali.
Greetings and Assalamu alaikum. I am honored to present this paper, which is titled as Application of Machine Learning for Screening Criteria of Enhanced Oil Recovery Methods, its implementation with optimum accuracy. Can you change the slide? These are the contents. Change the slide. As our colleagues earlier talked about ER methods, around the world ER methods are used to enhance the oil recovery of mature fields. They talked about how to optimize those mature fields through different techniques. But the very first question that comes in our mind, how do we select the best ER method? Usually in petroleum industry, what we do, we use conventional ER screening method or criteria, which is used by ER expert. But here what we are proposing a machine learning tool which will be able to predict the most suitable ER method for us. This is a screening criteria. What actually ER expert does, in ER screening criteria we have different parameters for different ER methods, and he chooses the best ER method for any specific reservoir location based on this criteria. Now, there is a simple misconception about machine learning and traditional programming that we have. In machine learning, what we have, if I were to simply put this, we have a data and then we have algorithm, then we have output. What we do, we train our model on a data and then it simply gives us a output. But it is just a simplification. If we exclude all the other optimization techniques, if you move to other problem statement around the world, okay, we know that the conventional screening criteria that we have is a human-based, rule-based, which can be subject to human biased. So what we are here proposing an objective screening tool. And the conventional screening method rule-based system which can be subject to human biased. By using machine learning technique, we can solve this. And second big problem that we are facing is imbalanced data set that we got. Actually, we got a real world ER projects data, which are successful ER projects, around 508 projects. But the problem with the data set was, we got the data set in which there was greater representation of steam injection of projects. And there were other ER methods which were underrepresented. So if we were going to train our machine learning model based on this data, our model would have overgeneralized and given us wrong predictions. So we are going to solve imbalanced data set problem as well with creating a screening tool which can be helpful for us selecting the most suitable EOR method. Aims and objectives. To first of all solve the imbalanced data set problem, which is causing the problem of overgeneralization and making our model biased towards specific class, especially if we talk about it will be biased towards the steam injection because it was in a greater quantity. Second, we are going to build 4 machine learning model we built. One was random forest decision tree, KNN, KN9 stands for K nearest neighbors, and the last one is XG boost, extreme gradient boosting. We built 4 machine learning models and checked and optimized those models, and we'll select which is the most suitable or best model for our screening. At the end, we will validate and evaluate our model by using 2 different techniques. One is hyperparameter optimization. We will use different hyperparameters which will optimize our model, and the very first dimensional reduction, where we applied principal component analysis to reduce the dimensions of our data because it was causing more computational power, taking so much computational power, and also causing the problem of overfitting. So we utilized dimensionality reduction problem. We utilized dimensionality reduction technique to solve the overfitting problem to improve the accuracy of our model. Scope of study, we tried to utilize different techniques of machine learning to see which method or which algorithm is going to perform pretty well or which will give us more accuracy. It's just to analyze like which algorithms are best for the screening of our model. Second, compare our machine, the screening tool with other conventional screening models or tools that we have through which we predict the most suitable UR method. And in the end, investigate the uncertain data that we had to see like the synthetic data that we generated, whether it has impact on our model or not. If it had impact, it's good, or if not, then we'll have to go and sort our data again. So, methodology. First of all, to get data, we had 500 projects. Then, when we analyzed the data, we had imbalanced data set problem that we solved by using UR screening criteria, where we had parameters. We utilized enhanced noise recovery criteria to solve the imbalanced data set problem. And we utilized heat map to pre-process the data set. Because in machine learning, we have different features. They have viscosity, and API gravity. There are different features that we had. We were trying to figure out whether there is a correlation between the output variable or features or not. If there is no correlation, then what we'll do, we'll drop that column. If I give you example, in our data set, we had also countries. So countries are relevant in order to decide like which UR method will be selected. So we reduce that column. This is a result and pie chart of a data which we use to generate scientific data. So this is a pie chart, the data we had after generating scientific data, where we reduced most of the data imbalance problem. But after that, we also applied another machine learning technique called oversampling to overcome the remaining data imbalance, and we can see that all the classes are now balanced. So this is the data to show you like which sort of data we had to make a machine learning model. You can see that we had a country, area and acres, formation, porosity, permeability, depth, API gravity, viscosity, temperature, oil saturation. At the end, we had a UR method for the best parameters. So this was the data set that we had, and we turned. This is just a sample. We had around 1,000 UR data set for samples. So now, moving to the most important part of our model building, feature selection, means the which sort of variables you're going to select, like whether there is a correlation between depth or output variable or not. If there is not, then it will reduce the efficiency of your model. And we used box plot to find out the outliers in our data set, to find out the most rare cases which were there. And we found out there were some rare cases of depth, where we had a, you can see in, I think, M2 or what, there was maximum depth of I think 1,000. So usually what we do, we reduce or drop these columns. But in particular imagery, to capture these diverse effects and diverse data, that was important to carry on this data. Then we come to that model deployment. We deployed our machine learning model on open source platform called Stimulate. We built an application which usually predicts the most suitable UR method, also gives you a probability of different UR method for a specific reservoir location. I'll show you as we move forward. So this is a methodology which I talked about. You have data acquisition, then scientific data generation, then selecting the most suitable parameters like depth, viscosity, if there is a collision, then making machine learning model. We build machine learning model, decision tree, random forest, attribute, and KNN. Then once you build a model, that's the simplest part. The important part is to validate model and increase the efficiency of your model. We utilize two techniques: hyperparameter optimization and dimension reduction. In dimension reduction, we try to maintain or keep the 95% of the important information of our model. Since the data it's very difficult to get data in petroleum industry, so it was very necessary to take these calculative steps. Selecting a best machine learning model which will perform best, model validation, checking through different validation, accuracy, optimization techniques like confusion matrix, F1 score, recall, to see like which model performs best and which one to select for the best screening. So if we talk about the results, this is a simple confusion matrix of random forest model. You can see that there is a true positive, true negative, false positive, false negative. If we just look at the false positive and false negative values, these are the values which were predicted wrong by our model. On the other hand, you can see that true positive and true negative are the values which were predicted correct by our model. So you can see that overall our model is performing pretty well on our data set. On the other hand, this is other evaluation metrics like precision, recall, F1 score, support, which tell you that for each method how your model is performing. This is the evaluation metric of decision tree. You can see that weightage is 85%, so model was performing pretty well. Evaluation metric of random forest, you can see that it performed much better than the decision tree. KNN, you can see that it also performed kind of equally to the random forest. And this is the evaluation metric of SGBoost, the last model we built. You can see that the weightage, average, and micro average is lesser than the all three models which we built. So it didn't perform as we expected it. This is the final result of our model. We performed cross validation where we divided our data set into 5 folds, and each fold was divided into training set and testing set. So these are the 5 results taken from the 5 folds where our model was trained and again tested by the data set. So you can see that the accuracy of random forest and KNN is equal, or they are performing pretty well and same, but XGBoost and decision tree underperformed as compared to these two models. So our random forest and KNN performed pretty well in predicting the most suitable method. So this is the interface we created, which where on the right side you put parameters, all the parameters I talked about, and it predicts the most suitable UR method for a reserve location. On the other hand, it also gives you the probabilities of all other methods that we trained our model, and it gives you the best suitable method. This is a video, you can run the video. So we are putting the parameters and different formation, and it will predict your most suitable UR method as well as give you the probability and bar chart for different methods. Overall, if we come to the conclusion that data imbalance was solved by scientific data generation, which performed increased efficiency of our model, and random forest our model and KNN performed pretty well. And if we can also, there are 2 limitations in our data. One, the economical factor, you can see in data was missing, so the methods which you selected, the economical factor was missing there. And the second, the best model or your method which is selected, that should be cross-checked by the UR expert. We cannot say it's an absolute tool. And that's all from my side. Thank you. If there is any question, I am ready to answer.
Thank you, Jawad, for a very good presentation. Now the forum is open for question. Please mention your name and association with your university or company, and then ask a brief question. Thank you.
Hi, Azan Bhutto from Mehran University. Jawad, that was quite a nice presentation. And my question is that can we take this tool as an absolute?
Definitely not. You cannot take this tool as an absolute tool because the accuracy you could see that it was actually 6%. And as I said, even if this method, screening tool, predicts a method, you cannot completely believe on it. So it should be cross-checked by the UR expert.
Okay, thank you, Jawad.
Assalamu alaikum, Wajid Ali from OGDCL. Beta Jar, how was the impact of synthetic data generation on your model?
Sir, as you could see that initially we had 500 for your projects, real world projects, but we faced the problem of imbalance data set. So we solved through the scientific data generation. And you could see that in accuracy, here that overall our models performed pretty well. The accuracy was 86%. So the impact of scientific data generation was great on our model.
So, if there's no more question, thank you, Jawad.
Thank you.
Our next presentation will be on evaluation of ladyfinger gel as an environmentally friendly clay swelling inhibitor in water-based drilling muds by Sadur Rahman.
Hello and welcome everyone. It's a pleasure to have you here. As we dive into an exciting conversation about evaluation of ladyfinger gel as an environmental friendly clay soiling inhibitor in water-based mud drilling. So firstly I introduce myself as I am the author and presenter Sadhu Rahman. My discipline is petroleum engineering. I am a student of NAD University and my core subject is drilling engineering. And these are the name of co-author who helped me in my research. The names are Muhammad Wasif, Shane Lalji, Sir Sayyid Imran Ali and Dr. Javed Hanif. So let's see the table of content which contain the topics like objective, introduction, methodology, result and observation and the conclusion with their subheading which we discuss in upcoming slide. So let's start with the introduction, which is to investigate the potential of ladyfinger gel as an clay soiling inhibitor and stabilize the Rani goat formation in water-based mud drilling. Next is the introduction. As the introduction of the research is as a drilling fluid as I have reflect the importance of drilling fluid, which is it reduces the friction between the well bore and the drill bit. It helps to cool the equipment. It carries the samples to the surface. It prevents the collapsing of the well. Over 75% of shale formation is used with water-based mud drilling as it is cost effective and easily to prepare. Next is the shale swelling. As the rock like shale swell when it's touched with water, so the issue is caused the swelling. So it is very crucial to control and manage the swelling by the preventing the swelling by inhibitor. So we use potassium chloride as mostly cases in the industry to prevent the swelling. Ladyfinger gel. As we are strict environmental rule leads to natural additive to water-based drilling. These are the green chemical replace the toxic operation, as ladyfinger is biodegradable, safe for environment. So, and the main thing, it maintain the water-based mud properties. Next is the attribute of Rani Goat shell. As this formation is sourced from the middle and the lower Indus basin of Pakistan, it consists of smectite, kaolinite, elite, mica, and dolomite. The depth of this formation is 1400 to 50 to 2000 feet. The cation exchange capacity is about 10 mil equivalent per 100 gram. This means it has the capacity to swell. Then come the methodology. For the extraction of ladyfinger gel, we first clean and wash the ladyfinger from the dust. Then we put it into the pot, fill with water and heat for 2 hours. Then with the help of Muslim cloth, we extract the silmy substance. Then the composition and chemical formula of ladyfinger. The composition of ladyfinger are galactose with the concentration of 25%, rhamnose with the concentration of 22%, galactonic acid with the concentration of 27%, and amino acid with the concentration of 11%. The chemical formula is the big chain of polymer at different monomer combine and form the big chain of the polymer. Next is the preparation of water-based mud. As for the research, I have prepared the 3 sample base mud, 10 ml ladyfinger, and the last is 20 ml ladyfinger. The chart is shown the additive and the quantities which I use for the preparation of 3 muds. Then come the measurement of rheological properties. As the rheometer is used to measure the rheological properties like yield point, plastic viscosity, gel strength, and apparent viscosity. Then the measurement of low pressure, low temperature filter press. As the filter press is used to measure the fluid loss. If the large value of fluid loss, it means that the sample is interacting with the formation, which is not good for the formation. I have used the nitrogen gas and the pressure of 100 psi to extract the mud, to extract the filter, to extract the to extract the shell sample, to extract filtration. Filter and the filtration loss to extract the measure at the filter pressure to remove the field loss and the to yes sir. As I use the filter press which is used to measure the filtration loss, as high filtration means that the mud is going into the formation and it is not good for the formation. So I have used the and I will get 6 reading at the interval of 5 minutes. The compressed nitrogen gas was extracted with the pressure of 100 psi. Then is the process of formation of shell pellet. As 15 gram of shell pellet is used and put into the compactor and exert the pressure of 8000 psi for 30 minutes for the formation of the pellet. Then there come the contact angle measurement method. As the contact angle is used to measure the hydrophobicity of the sample, the method is we have put the mud sample on the pallet, and if the contact angle is greater, it means it has greater hydrophobicity and it swell less. Then there comes the result and the observation. As the contact angle analysis, we can see the chart by the addition of lady finger in the base mud, the angle is being greater. It means that the sample is hydrophobic in nature. Then the impact of lady finger on plastic viscosity. As plastic viscosity play a crucial role in the drilling fluid, so its API standard is giving, which is 8 to 35 centipoise, and my reading are applicable for this. Then is the impact of lady finger on apparent viscosity. As apparent viscosity is directly affected by the shear rate for non-Newtonian fluid. As the base mud shows the viscosity of 17 centipoise, 10 ml lady finger shows 20 centipoise, and 20 ml shows 28.5 centipoise. Then there comes the impact of lady finger gel on yield point. As the yield point has the potential to carry the substance to the surface, its API standard is also given, which is the minimum is 5 and the maximum is multiple of 3 times plastic viscosities, and the recording also fulfill the desired consideration. Then is the impact of lady finger on gel strength. As the gel strength has the potential to hold the cutting in the well, so its API recommendation also given about 10 minutes is 2 to 35 pound per 100 feet square, which is also fulfilling the research. Then the analysis of filter press. As we can see that by the addition of lady finger in the base mud, the filtration loss is getting reduced, which is suitable for the formation. Analysis by ImageJ software. For more confirmation, I use ImageJ software. As we can see the result of 20 ml lady finger, which is comparatively better than the rest of two. As the shell pellet is in good condition, a less amount of sample stick to it, but the rest of the pellets are broken and lot of amount of sample are stick to it, which is not good for the drilling operation. Then the mechanism of preventing shale swelling. As this is pretty simple, as we are using water-based mud which contain H plus ion, and shale is performing as negative. When it collides, it swell. But when we add lady finger in the base mud, so it stops the H plus ion to contact with the formation and it prevents swelling. Then last is the conclusion. As lady finger is cost effective and easily to prepare, all the API standard are in the range of my research, and lady finger prevent the migration of water into the shell, the surface of pellets become hydrophobic. Lady finger gel is highly efficient in preserving cutting, and the last is shell swelling is significantly reduced when it contact with the lady finger. Thank you. Any question?
Assalamu alaikum. My name is Abdur Rahman Misbah. I'm a fresh petroleum engineering graduate from NED UET. Great presentation, Saad. I was wondering that you mentioned that you used shale from Ranikot.
Yes.
And you could have used shale from Ghazij. So I think there must be some greater proportion of shale in Ranikot. Do you know the percentage? The percentage of shale?
The percentage is
at
about 30% in the Rani Good formation of shale.
Okay. Thank you. Thank you so much. Okay, understood.
Just I want to know that ladyfinger, is it a chemical name or something else?
Is a green chemical, is a vegetable. So it is cost effective and easily available in market.
So how you have used this ladyfinger gel? Is it available in market or you have created your own source at
As-
laboratory level?
As I was giving the composition, these are the polysaccharide. If they are in the ladyfinger, and it encapsulate the water, so it prevent the water to contact with the shale, so it swell less. Yes. In- we have to prepare it. Yes. The
My नहीं ना मुश्किल निकल ठीक है. My question is, there are hundreds of polysaccharides in the market. Why we are stressing upon the ladyfinger to extract a gel from this specific vegetable? Why not something else? Because there are more of polysaccharides available in the market. Why ladyfinger? I didn't get the point, because the results are very much similar to the base mud. They are not significantly have been improved from, if you watch them with respect to the base mud. They haven't improved result. They haven't shown the okay.
sir, but it is in
जी फजल रहीम सर OGDCL okay जी.
sir, the result are under the consideration of API, so we considered it and is easily available. So but the thing is, we have to make the silmy substance. But it is in the API standard,
Okay.
fulfilling the API.
One minute. I really appreciate you. You are doing the innovative work, okay?
Thank
because
you, sir.
this ladyfinger, the substance you have extracted and you have got experiment, okay?
Yes,
and
sir.
that give, if it is not significant results, let's say, if it is have a little improvement, so you can improve it. We all over here are from OGDCL drilling fluids team. So just improve its testing and
Yes, sir.
get more better results. If you have a good and better results, we will improve it in the future, and we will have a good inhibitor as compared to other inhibitors, and must do some cost effectiveness and comparison with other inhibitors. Okay?
Okay, sir.
Thanks.
Thank you, sir.
The next paper is CO2 saturation effectiveness as an environment benign and its application in petroleum industry by Muhammad Usman Khan.
Good evening, everyone. It's been pleasure to be presenting my paper at ATC 2023. The title I am presenting, that is CO2 sequestration as environment benign and its application in petroleum industry, a review-based paper. This content and outline this paper is based on research background, problem statement, objective of studies, research methodology, and results and discussion, comparative analysis. Research background. As we all know, that CO2 concentration has been increasing due to the burning of fossil fuels and deforestations. This graph shows the amount of CO2 that since last 50 years, and as we can see that the trend of this graph is increasing, and in coming years the CO2 concentration will increase. CO2 sequestration, basically it is the capturing, removal and storage of CO2 from the atmosphere. Either it can be ejected into geological formation for storage, or it can be used for injection to increase the recovery from depleted reservoirs. Problem statement. Basically, the high concentration of CO2 in the atmosphere causes global warming. The second one is that to recover the oil from the depleted reservoir, but the CO2 EOR are cost intensive. The objective of study is that to isolate, extract, and capture CO2 from the atmosphere to reduce the global warming. The second one is to improve the oil production from the depleted reservoir. And the third one is to reduce CO2 EOR cost by reservoir management and sourcing the CO2, sourcing cost-effective source. Research methodology. Basically, this study is based on following case studies such as the sources of CO2 into atmosphere, capturing of CO2 from the atmosphere, enhanced oil recovery with the CO2, and the last is the effect of miscible CO2 on the recovery. This is a technical route of this paper, how it has been done, the topic and its case studies has been discussed, and their comparative analysis. The sources of CO2 into atmosphere. There are basically two main sources of CO2 into atmosphere. The one is that natural sources and the other human. The natural sources include volcanic activities, oceanic release, and respiration by plant. The second one is human. This deforestation and fossil fuel combustion, both by transportation and industrial processes, causes CO2 into atmosphere. And capturing of CO2 from the atmosphere, it is done by direct air capture DCA. It involves two processes, chemical absorption and physical absorption. In chemical absorption, we use solvent-based absorbent in which CO2 has been absorbed. And in the physical absorption, we use solid absorbent, which absorbs CO2 from ambient air. Afterward, when CO2 is being extracted from the air, it can be used, captured CO2 can be used in geological storage or to enhance oil recovery for mineralization and carbon products. CO2 EOR, basically the second case study is that enhanced oil recovery with CO2. First of all, we have to do reservoir characterization. So then the second thing is sourcing CO2 from sourcing CO2 from industries or constructing a plant, CO2 capturing plant. The third one is if we have source the CO2 from industries, how we can transport it. The transportation can be through pipelines or through tankers. Then injection well. Then we inject the CO2 into the reservoir. Afterwards, when CO2 is being injected, we have to monitor the CO2 pressure and injection rate. Oil recovery is based, we have to monitor that what are we producing, what type of oil is being produced and what is the producing rate. Produced fluid handling, and we have to separate that produced fluid, oil, water and CO2 is being separated. The CO2 we have injected, it can be recycled and re-injected in this process. The third one is the effect of miscible CO2 injection on production recovery. First of all, we have to encounter the interaction, how CO2, when the CO2 is being injected, how it interacts with the crude oil. The second, afterwards the interaction, it enhances the oil mobility. That also causes mobilization of residual oil and improve the sweep efficiency and pressure maintenance. Reduce the interfacial tension. The injection of miscible CO2 injection basically reduce the IFT. Afterwards, the CO2 can easily move the IFT between the oil and the rock. Here, the case study one, basically there are the sources, it has been discussed, shows that the sources of CO2 in the atmosphere are fossil fuel combustion, deforestation and land usage, industrial processes, agriculture and natural processes as have been discussed before. Here the direct air capture. We absorb or extract CO2 from the atmosphere through DCA. It involves Adsorption and absorption. In adsorption, we use solid solvent such as zeolites, alumina, and silica gel. Basically, the CO2 molecule got stick on the surface of the absorbent, as I have shown in the diagram. It tells that when we inject the CO2 here, it's been stick to the surface of that solid absorbent. Afterward, how we can separate that CO2 from the surface of that solid sorbent through the pressure and temperature swing. In the same way, to absorption, we use liquid solvents such as monoethanol amine. It's just a chemical-based reaction when CO2 has been extracted from the atmosphere. The capturing process, basically air is being taken from the vent fans and captured from sorbent, solid or liquid one, and again by temperature and pressure swings it can be separated. Enhanced oil recovery with CO2. When CO2 is being injected into the reservoir, the first thing is that miscibility. Miscibility is the first primary interaction. When CO2 gets dissolved in oil, it makes single phase. However, the miscibility depends upon, miscibility is pressure dependent. Miscibility is achieved by minimum miscible pressure. When the CO2 gets dissolved, it swells the oil. By swelling the oil, it decreases its density and increases its volume. Afterwards, it causes reduction in the viscosity of that oil. How viscosity has been decreased? By as dissolved CO2 act as a solvent and thinner. And dissolution also reduces the CO2, also reduces the viscosity of the oil. Dissolution, by the dissolution of CO2 into oil, it cause reduction into the reduction of IFT, interfacial tension between the rock and the oil. So it make the oil more mobilized and it can be easily pushed toward the production well. Pressure maintenance, as it has been done in depleted reservoir. So the injection of CO2 just artificially maintain the pressure of that reservoir. And pH change. By injection of CO2 into that reservoir, it also cause pH change by the reaction of like CO2 and water by making carbonates, that's making H+ ions. So it may be acidic, it can cause change in pH change. Factor influencing the to choose the reservoir for CO2. The first one is reservoir characterization. We have to characterize the permeability of reservoir, porosity of the reservoir, as well as the heterogeneities, that how its permeability are and how its porosity, like it has high porosity, so there is high success rate of CO2 injection. And the reservoir must have a permeability for sufficient movement of CO2 and the oil. The second one is oil properties. The oil properties, the oil viscosity is the main thing, that if an oil has a high viscosity, so the success rate of CO2 injection is more. And the oil saturation. The second thing is that we must know the residual oil saturation that is remaining within the reservoir. Geological and petrophysical factors, that as reservoir depth also affects temperature and pressure and rock types, as well as the cap rock integrity. Miscible CO2 EOR process. It involves the following processes. That first we have to characterize the reservoir, what's its structure, how its rock properties are, permeability, porosity. Second thing is we have to characterize fluid characterization. That is like how the oil behavior within the reservoir is, what are their temperature and pressures, what are the API gravity, and as well as we have to know about the CO2 as well. Injection welding. When we have to inject CO2 to the injection well, before that we have to do compression and digestion of CO2 to remove the water, other impurities from that CO2. We need CO2 in supercritical condition. As this diagram shows, that the first one shows that where the miscibility didn't achieve, and the second one shows that the miscibility front is displacing the maximum moist toward the production well. So it shows that the miscible injection have more recovery as compared to immiscible or the other injection that doesn't get miscible with the oil. The immiscible, however, the difference between them is that in immiscible, CO2 injection can act as an artificial gas cap. As the diagram shows, that when we inject CO2 into the reservoir, it can show that it creates an artificial gas cap through which we can push the oil towards the production well. However, the CO2 injection patterns, there are basically three: continuous injection, cyclic, and WAG. In continuous, the CO2 is injected without any interruptions. However, it is a steady and uniform constant supply of CO2, so it improves the efficiency. It is effective in homogeneous reservoir. The second one is cyclic. The cyclic is basically two phase. Number one, it is injection phase. The second one is soaking phase, where the well is shut in. Water alternating gas. Basically, water and gas are being injected by the two steps. First, we inject CO2, then we inject water. For CO2, it has been for dissolution, and for water, it displaces, it pushes the oil towards the production well. Effect of miscibility on production recovery. Here I have taken the results of a field that is known as Corona field located in Austrian Basin. They have concluded that the miscible CO2 injection have more recovery factor as compared to naturally producing reservoir. Therefore, the miscible CO2 injection is practical method in increasing the recovery factor. The comparative analysis of these case studies interplay a complex environment and industrial processes. The fossil fuel combustion that produces CO2, land usage, and causes that all of them causes CO2 emission to the atmosphere. To encounter this issue, we use direct air capture, CCS, carbon capturing storage, and to remove the CO2 from the atmosphere. Meanwhile, enhanced CO2 ER involves injection of CO2 to depleted reservoir to enhance the oil recovery. Sufficiently miscible CO2 injection is highly cost-effective method. So that's why we have to manage CO2 for promoting the injection of CO2 into the well. Conclusion: the conclusion is based that CO2. Basically, the production of CO2 in the atmosphere is increasing day by day. To encounter this step, we have to use DCA. DCA is more effective because the sorbent we are using, they can be recycled and reused, so it's least cost effective. Miscible CO2 EOR is more preferable than immiscible CO2 EOR. Water alternating gas is a maximal high recovery as compared to the other recovery factors. And the last one is economic availability. The economic availability of EOR depends upon the various factors such as cost-effective sources and capturing method. These are sustainable development goals that correlates with my paper. That's making cities and human settlement inclusive, safe, and resilient for sustainable. Take urgent action to combat climate change. And the last one is to protect and restore and promote sustainable use of terrestrial ecosystem sustainability, manage, protest, combat dispersion. Thank you.
My name is Mohammad Bilal and I am an undergraduate of UET Lahore. So I have a question that when we are doing CO2 injection, it may produce H2CO3.
Yeah.
So how you are going to control that?
Basically, it's been a review-based paper. It's not experimental. The thing you are asking that can be encountered by doing the process, it's an idea I'm presenting, that my idea to do this to reduce global warming as well as to increase the production from the depleted reservoir. For this, we can do a recycling process, or we can re-inject that thing into other formation to reduce that by separating them.
Actually, the main concern was that H2CO3 will be damaging our casing, and it may also disrupt some water tables, and it will also create, pollution.
I'm saying that I am just promoting the idea. I haven't done the experimental work, so I cannot answer this question that what we can do about this.
Okay, my name is Iman Rafiq and I'm also from UET Lahore. So my question is that you're using the carbon dioxide from the nature, like you said there are two processes, from the air capturing or from inserting into the well.
Yeah.
If you are doing the two processes, okay, let's suppose you are doing inserting into the well, that it is cost effective. Like everything we do in the industry, we just first of all we see that whether it is cost effective or not, whether it's we have any productivity from anything, or we have cost effective this process or not. So does it
basically, the first thing is about that you are saying the cost of CO2 sequestration is high. Yeah, that's true. But the second thing, on the other hand, we can say that the global warming is also a great issue. We are producing that thing into the atmosphere. So to overcome that effect we are producing, we can overcome that cost of that. Or second thing is that, like if we are injecting CO2, there is no, we cannot do something as like, if we are injecting CO2 into the reservoir, it's highly cost effective. I'm sorry, I just forgot what I have said.
I said that whatever we do in the industry, first of all, the main thing that we are seeing is whether it will give us benefit or not. Is it so?
Yeah, it will give us benefit in two ways: reducing the global warming, and secondly, it is enhancing the oil recovery. It's beneficial if you can see that.
No, in the case of oil recovery, I am seeing that in that case, it is beneficial. Like in the industry, like in America, the CCUS process they are using
Yes,
the CCUS process.
Yes.
But according to some reports, that process is not cost effective. Like they are investing more on that processes.
It may be. It's depend upon the residual oil saturation in the reservoir, how amount of oil is remaining in that reservoir. So if we have a large amount of oil, so it will be more cost effective.
Okay, thank you.
The next presentation is on optimization of choke size for two-phase flow using artificial intelligence by Fazal Hussain.
Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Assalamu alaikum, ladies and gentlemen. I am Fazal Hussain Lashari, and I am honored to be here in front of you as an undergraduate student of Mera University of Engineering and Technology, Sheikh Zulfikar Ali Bhutto Campus, Khartoum. So today the topic of my presentation is optimization of choke size for two-phase flow using artificial intelligence. Today's journey involves the fusion of tradition. So here are the contents of the presentation: introduction, objectives and main innovations, methodology, research outcomes and discussions, and finally we have concluding remarks and references and acknowledgements. So let's talk about the introduction. So here is the background of the study. The study of flow through chokes is very much important in petroleum industry. This can be due to several reasons, like its ability to protect surface equipment. It can avoid sand problem. It can avoid water conning and gas conning, etc. So different correlations have been built to use, have been developed to study flow through chokes, like Gilbert, Baxendale, Rose, Ekung, Usman and Dokla, and many more. So, but those correlations are not 100% accurate as given by the Ella et al. So currently artificial intelligence is growing more popular nowadays. So applications of AI is discussed by different researchers like Lee et al., Kwang et al., Shahab, and Perth Solanki. So here is an overview of the work. This work deals with the optimization of choke size for two-phase flow using two machine learning techniques like artificial neural network and decision tree. The models built using these techniques were implemented using MATLAB software, and the results of this study will encourage other researchers to work on different machine learning techniques like ensembles and many more recent technologies and in the petroleum industry. So here at the right side of the slide, we can see the structure of artificial neural network. It consists of three layers: the input, the hidden layer, and the output layer. And let's talk about what is artificial neural network. Artificial neural network teaches computer to process data in a way that is inspired by human brain. It uses interconnected nodes and neurons in a layered structure that resembles the human brain. So here we talk about decision tree. What is a decision tree? It's a graphical representation of all the possible solutions to a problem according to certain conditions. The tree simply starts with a node named as root node, which represents the entire data. The tree then splits into smaller nodes representing the subsets of the data, and at last this process continues until a stopping criterion is met. So what should be the stopping criterion? This can be about a certain level of accuracy or the minimum number of data points in the leaf node. So here is the structure of the decision tree. You can see the root node then splitting into smaller nodes, and then finally we have leaf node. So main objectives and innovations. The objectives of this study is to predict choke size for two-phase flow using two machine learning techniques, artificial neural network and decision tree. So the main innovation of this work is that we are comparing decision tree and artificial neural network in two-phase flow, and we will be concluding that which method is giving the best predictions when comparing these two techniques. So here is the methodology of the work. We reviewed the literature, the data was collected, we pre-processed data, and we applied artificial neural network in decision tree. We trained, tested, and validated our models, and at last we watched that if the error is acceptable or not. Then we compare the both results, like decision tree and artificial neural network, and we finally come to any conclusion that which method is very good, is better. So the data used in this study was collected from a research paper, from a reputable research paper, El-Haj et al. And Al-Khamis et al. So this is the parameters. These are the parameters that are used in the research paper. In this work, choke sizes, oil and gas flow rates, upstream and downstream pressures, and we have oil API, gas relative density, and mixture relative density. Mixture relative density was calculated by the formula given under the slide, and was put as an input parameter. So we used 500 data points, and 70% of those data points was used as training set, 15% for validation, and 15% for testing. Here at the right side, you can see the table 1, which shows the statistical analysis of the raw data we have used. So before feeding it to the network, it must be seen that what are the relations between the parameters, how the parameters are related to each other. The relations between the input and output parameters were studied to build the models, and table 3 shows the relationship between the input parameters and the output parameters. White numbers are these. These numbers are correlation coefficient. What is the correlation coefficient? A correlation coefficient is a number which represents that how much your data is how much your predicted data is resembling the actual data. Number 1 shows the 100% accuracy, 100% that your data is matching, and while 0 represents that no correlation at all. So it shows that in this table we can see that it shows that the dominant factor affecting the choke size is flow rate rather than the upstream pressure. The negative sign in this table indicates that the input parameter is inversely proportional to the output. So as we can see, we cannot put directly feed data into the network because it carries a large number of data points, and each parameter has different scale. So we have to normalize our data. So we have normalized our data by this formula, which was used in Al-Khamis et al. X norm is equal to xi upon a standard deviation of xi. So after normalization, we have to check that whether normalization has affected our data or not. So we have to recheck the correlations between the input parameters and the output parameters. So we have once again checked the correlations, and we found that there were minor changes in the outputs and in the relations which were taken. So we were ready to proceed. And then this is the statistical analysis of the logarithmic data. We are using some transfer functions like log sigmoid, which uses logarithmic data. So we have to convert the data into the logarithmic form. So this is the statistical analysis of that logarithmic data, and we can see here the correlations have been the relations between the input parameter and output parameter were once again checked, because we have to see that whether the logarithmic form has affected the data relations between each other or not. So we once again saw that minor changes occur in all the data we have converted into logarithmic form. So we were ready to go. So research outcomes and discussions. Artificial neural network. Let's talk about artificial neural network. We use two types of general layer feed system: cascade forward, and feed forward. Why we use these type of general layer feed system? We used because feed forward do not gives feedback, but cascade forward does this do this. So that's why we use two different types of general layer feed system. A comparative analysis of feed forward and cascade forward is given in the table. We have used different training algorithms and transfer functions to compare these two techniques. We can see that the cascade forward, which has the training algorithm train LM and the transfer functions log, sigmoid, and purlin, has given the best results. Then let's talk about the feed forward comparison. We saw in the previous section that log, sigmoid, purlin was giving the better results as compared to the other transfer functions. So we take log, sigmoid, purlin function as and we take different training algorithms to see whether which training algorithm is giving the best results. We finally concluded that the cascade forward was giving the best results with the training algorithm train LM and the log, sigmoid, and purlin transfer functions. Here at the left side, you can see the structure of artificial neural network we have made, and here at the right side, you can see the regression plots of the cascade forward neural network. We can see the training, the validation, the testing, and all data. So let's talk about decision tree. Three types of decision trees, regression trees were used: the medium tree, fine tree, and coarse tree. We found that medium tree was giving the best results and the better value of mean squared error in validation and in testing as well. So here is the medium tree responses on the testing and the training data. The left side shows us the predictions of medium tree on the training set, and the right side shows that the medium tree predictions on the testing set. The middle line shows the best predictions, and the blue points are showing the observations we have got. So here is a statistical analysis of both methods. We have concluded that artificial neural network was giving better results as compared to decision tree, and minimum value of mean squared error as compared to decision tree. So here are the concluding remarks. We concluded that artificial intelligence can be successfully used as to predict choke size for required flow rate in two-phase flow, and we concluded that artificial neural network gives better results as compared to decision tree, and it can be utilized. So here are the references that have guided us to do this work, and here are the acknowledgements of all the persons and my colleagues that have helped me, my teachers that have helped me, and to do this complete work. Thank you so much. If you have any query, you can ask.
Thank you, Usman, I guess. Fazal, sorry. It was a good presentation. I just have a minor thing to ask. There is a known problem with artificial neural networks of overfitting, that they tend to overfit the data, and when they do so, the accuracy with which we predict the target out of that model, that network, it tends to be greater. So what did you do to tackle this particular problem? Number one. Number two, there is a usual 60-40 train test split that we use when we are training the model and when we are testing it. So you showed us that the train test split was 70, 15, and 15.
Yes, sir.
So isn't it going to overtrain the model and then give false positive results? Thank you.
Thank you so much for asking this question, sir. So the first question, which was about the overfitting.
Overfitting.
The overfitting. So overfitting means that your validation is going upward, while in beginning your validation goes upward while your training also goes upward. But in overfitting, what happens usually that your validation is now going downward, and your training and your testing response is going upward. So I was checking that how these responses are going upward or downward, and then I have just put those types of validation checks, and I have just completed and stopped the training when I found that it was good. And the second question.
It was about the train test split that you have used,
Yes,
70, 15, 15.
Yes, sir. I'll use 70, 15, and 15 because we need large number of data sets, large number of data points, because the larger number of data points we have, the more better we can train our network. So in this way, we used 70% for training, 15% for validation, and 15% for testing. I hope that answers the questions.
Thank you.
The next presentation is on hydraulic fracture design and optimization in a tight oil reservoir using different frac fluids and proppants in consideration of varying formation by Minahil Ali.
Hello everyone, and thank you for having me today. I'm Minahil Ali, and for today, the topic that I'll be delivering a presentation on will be hydraulic fracturing design and optimization in a tight oil reservoir using different frac fluids and proppant in consideration of varying formation permeability using the software FracPro. Moving on with the presentation. The structural outline for the presentation will be, firstly, can you please move on? Other way around. Okay, thank you so much. Firstly, the first will be modeling the reservoir, okay, in which we'll be discussing the reservoir properties and the formation, the type of formation that we'll be going with. Secondly, we'll be moving towards the fluid and proppant selection for the fracturing job. Then we'll be moving towards the case study development, in which we'll be designing a job, and for that job we'll be then developing other cases with varying proppants and fluids. Then the developed cases will be compared in the sensitivity analysis, and at the last we'll be having the outcomes or results. So firstly, moving on towards the reservoir modeling. Here I have gone with a sandstone formation with a permeability of 0.1 millidarcy and porosity of 10 with a pay zone of 100 feet. The overlaying and underlying formation is shale, and the stresses are quite high as compared to the formation reservoir itself, which will be confining the fracture within the reservoir. Secondly, moving on, we'll be discussing the fluid and proppant that has been selected. So there are two major fluid types that I'll be going with: the high viscosity fluids. For the high viscosity fluids, I have opted for three fluids: H1, H2, and H3. H1 is oil based, H2 is foam and gas based, H3 is purely foam based. Whereas for the low viscosity, I'll be going with L1 and L2 that are gas based and oil based respectively. For the base case, I'll be just going with pure water, and I'll be comparing these cases in the further slides. Moving on, the proppants that I have selected are four. Two of those are of mesh sizes 2040, and two of those are mesh size of 4070. These are of the proppant A is ECPAC, that is resin coated sand. Proppant B is carbolite, that is low density ceramic, and then respectively proppant C is badger sand, that is pure sand, and proppant D is carbolite low density ceramic. Moving towards the third step of our structural outline, we'll be going towards the case study development, in which firstly we'll be designing the job. For our case, I have designed a 60-minute job in which our slurry rate was kept constant of 5 barrel per minute, and the maximum proppant concentration was 5, and a total of 360 barrel of fluid and 24 kilopounds of propellant was pumped. Considering this job, we developed 4 base cases that were developed using 4 respective propellants, that are propellant A, B, C, and D. Propellant A and B are the fracture design is listed as this. Here you can see the propellant B tends to offer more dimensionless conductivity as compared to propellant A, because it has the crushing strength. The crushing strength of Carbolite 2040 is more as compared to ACPAC 2040. Further moving, we have propellant C and propellant D. As the mesh size has been changed to 4070 and has become more, the size has reduced. This reduces the dimensionless conductivity to much extent. This means that the fracture that was as you can see, that there is a general trend that the high viscosity fluids H1, H2 and H3 have a generally low fracture length as compared to the rest of the fluids, because the leak off for this is low. For the high viscosity fluids, the leak off is low, whereas this the fracture length is low, but once we move to the average fracture width, the average fracture width of these high viscosity fluids is much higher. Again, the reason is same, because of the low leak off. Moving on, the important part, the net pressure. So the net pressure is again high for the high viscosity fluids, because the fluid is being pumped through the perforations into the reservoir, as well as it is carrying the propellant. So again, carrying the higher viscosity fluids with high viscosity and the propellant, this increases the net pressure to be much higher as compared to the rest of the cases. Further on, lastly, last but not least, the dimensionless fracture conductivity. We can see the dimensionless fracture conductivity for propellant B for each of these cases is high. This means that the permeability that the propellant B has to offer is much greater as compared to propellant A, C and D. Because it was Carbolite 2040, the size is greater, the size is larger, so the permeability it has to offer is much more. But whereas the propellant C, that was Badger sand, because it was sand, the crushing ability was low, and so it was crushed, and much of the propellant and the closure stress closed the fracture, and these cases have a low dimensionless fracture conductivity. Now, from these sensitivity analysis, we came up with 2 of the best cases, one for the high viscosity and one for the low viscosity fluid. For the high viscosity fluid, we got BIN 6040, that was foam based, and this was gas based. Again, the propellant was same, propellant B, but as you can see, for the high viscosity fluid, it was the leak off was low. The leak off was low, and so we got a lower fracture length as compared to the fracture length of the low viscosity fluid, which has a higher leak off. So the average fracture width was again the average fracture width was larger, but for the low viscosity, the average fracture width was low. This brings us to the high viscosity, to the dimensionless conductivity. Dimensionless conductivity is a product of fracture permeability to the width, and so the width in this case is high, and the width in that case is low. So that's why the fracture dimensionless conductivity is less for the low viscosity as compared to the high viscosity. Now we took these optimized fracture design, these fluids, and what we did was we varied the formation permeability to see what happens to the fracture that is developed. So as for the base case, this was the fracture length, this was the fracture conductivity, and that was the fracture average width. Once we reduce the permeability, we can observe that the fracture length has increased. The fracture length has increased, but at the same time, the fracture width has reduced. The fracture length has increased because the leak off is low. Whereas if we increase the permeability, the leak off becomes high, and so the fracture does not propagate much in the formation, but the width of the fracture is much more high. Same goes for the low viscosity fluids, if we observe the dimensionless fracture conductivity, it is much lower in case we reduce the permeability. This was because we followed the same job design, and because the fracture volume has increased due to the fracture length has increased. So once the fracture volume has increased, we can place more propant or pump more propant into the fracture. So what we can conclude was that the propant concentration, the dimensionless conductivity of the fracture is majorly affected by the propant density, the propant size, and the strength of the propant. Further on, if we observe the propant propagation and geometry, we see that the fluid viscosity and the leak off of the fluid majorly affects the propant propagation and propant placement and the fracture geometry in the reservoir. Further, if we observe the permeability, as we saw, reducing the permeability increase the fracture length, but reduces the fracture width. This tends to increase the fracture volume. Hence, if we optimize that our job design, we can increase the dimensionless conductivity of the fracture by putting more propant into the formation or into the job. Thank you, and that's all from my side. If you have any questions, feel free to ask.
So, any questions, audience? What is more important, fracture half length or the conductivity?
What is more important, the fracture? The dimensions for our case, we were going for a much higher fracture dimensionless conductivity, and generally because the dimensionless conductivity is more important because it tells the permeability that the fracture has to offer. So if we compare the length and the fracture conductivity, if the fracture has propagated more into the reservoir, but after some time due to the closure stress, the fracture has closed and the propant cannot go with more into the fracture. So this means that the dimensionless conductivity is more important as compared to the fracture length, because if we have a good dimensional conductivity, this means that the permeability and the propant concentration within the fracture is much greater and is more desired fracture.
The topic for the next presentation is Fenugreek acts as an eco-friendly inhibitor in water-based drilling mud to modulate the rheological and filtration properties as well as hydration characteristic of the shale by Rida Siddiqui.
All right, so Assalamu alaikum to one and all. Hope you all are doing great. Today I'm here to present the new green inhibitor in oil and gas sector. So we could modulate the rheological properties and the filtration control against shale soiling. I, Rida Siddiqui, the presenter. Could you change the slide, please? And the author of this research, and these are the co-authors. So in table of content, you could see this, that we are going to discuss these topics in today's presentation. So basically, we have two objectives of this research. The first, or the primary objective, is to find out the potential of the fenugreek, means that to find out the potential of the green inhibitor that we are introducing. And the second one is to find out the long-term solution in our oil and gas sector as a green additive, for the green additive. All right, so let's start our presentation with drilling fluid. The primary function of the drilling fluid is to carry cuttings from the wellbore and bring it back to the surface. So we could categorize the drilling fluid as synthetic-based drilling fluid, water-based drilling fluid, and oil-based drilling fluid. But today, our main topic or our main focus is water-based drilling fluid. Why? Because it is friendly, environment friendly, cheap, and easy to formulate. But there is one problem that rises while we use the water-based drilling. And what's that? It's the hydration of shale, or you could say the shale soiling. So what is shale soiling? So basically, when water-based mud comes in the contact with the shale formation, due to the ion exchange process, the shale formation starts swelling, or you could say that the shale start hydrating. As a result, it start deforming and start collapsing, or just start collapsing in the wellbore. So to reduce this problem, we use different inhibitor, and I'm here to present the green inhibitor in oil and gas sector. So as we are saying that the shale formation start deforming, so we are not just saying that. I performed the test by extracting the sample from the Badin field at the height of 7 to 40 till 7 to 90 feet. And then we performed different rheological and filtration test powder. And for the efficiency, what you have to do, take that powder in the sieve shaker by using the sieve of 0.21 mm, so that you could get the fine grain powder. You could not find any kind of hurdle while performing the rheological test. All right, so we have made the fenugreek powder, and we have extracted the shale from the formation, from the Badin formation. What you have to do, now we'll make 3 different types of mud. The first one is base mud, and the second one is sample 2, sample 1, in which we add 1% of fenugreek, and the third one is sample 2, in which we add 2% of fenugreek. And by preparing these 3 muds, we will perform different experiments. All right, so the first one is the first experiment to find the rheological property. We find out the plastic viscosity, yield point, and the apparent viscosity. And for the second LP-LT test, LP-LT filter press test. The third one is the immersion test. In immersion test, what we will do, we take the 15 gram of powdered shale and place it in the hydraulic compactor cell. As a result, we get the shale palette, and then while performing the result, we use that shale palette. All right, the shale palette that I just tell about in the last slide, now we are going to use that shale palette here for the contact angle measurement test. So what you need to do, you could see the setup here. First, take a shale palette and drop a droplet of drilling fluid by using the syringe. And through this setup, first you have to take a picture, and then you can find the contact angle. Repeat this process 2 times, 1 for the drilling fluid, 2 for the 1% fenugreek, and 3rd for the 2% fenugreek. In this way, you could find out the contact angle of all 3 drilling fluids. And then we have the results for the flow curve. We, by using the 3 different drilling fluid, we perform the test, and we find this graph against shear stress and shear rate. You could see we have increasing trend here, which means that our fenugreek is effective. All right, so now we are gonna discuss the rheological properties one by one. First one is the plastic viscosity. You could see that there. The first one chart is base mud. The first one bar is of base mud. The second one is 1% of fenugreek, and the third one is 2% of fenugreek. You could see that we have increasing trend of the plastic viscosity, means that our green inhibitor is increasing the plastic viscosity, but this viscosity lies within the API standard, so we don't need to be worried about that. Now we have apparent viscosity. Here we also have the increasing trend, and here we also have the increasing trend, and the trend is increasing because we are adding the percentage of our green inhibitor in the oil and in the drilling fluid. Then we have gel strength. So basically it's the ability of the drilling fluid to suspend the cutting within the well bore. So you could see that it also follow the same rule. It means that it also has in the increasing trend. Then we have API LPLT filter press test. There we have decreasing trend. Why? Because when we perform this test, okay, let me tell you again. The first one is base mud bar, the second one is 1% fenugreek, and the third one is 2% fenugreek. So it has decreasing trend because our filtrate, the liquid part from the mud, when it start leaving the mud, the content is decreasing. As a result, we have thin mud cake, which is a good thing. While, because if we have thick mud cake, it start increasing the problem in the drilling sector. So this chart shows that our drilling mud is, the thickness of our drilling mud is decreasing. Then the last is the graphical representation. In here, the experiment that I performed, you could see that the drilling, after the LPLT test, the mud cake thickness, the thickness of the mud cake is start decreasing. Then we have immersion test. So what we do in immersion test, we have 3 different pallets of shale. We soak it over for 24 hours in the different drilling fluids, and after removing it, you could see that the topmost picture, the base mud, the drilling fluid is coated over the shale pallet, but it's deforming. Why? Because it's the water-based mud, and I've already told you guys that when water comes in the contact with the shale, it starts deforming. So you could see it. On the 1% fenugreek, you could see that the deformation is very less. It means that our inhibitor is very effective and it's working. On the last picture, 2% of fenugreek, you could see that the deformation is not much. In fact, the shale pallet is not deformed, and it's properly covered with the drilling fluid. It means that you could see through the experiment that the deformation of the shale start decreasing while increasing the concentration of the fenugreek, that is the green inhibitor. All right. So in contact angle measurement analysis, you could see that the angle is in from the bottom till up. You could see that the angle is start increasing. It means that the hydrophobicity of water is increasing. Hydrophobicity of shale is increasing. And you could find from that picture as well. All right. I could sum up my whole presentation through this slide. Look. In first picture, first we'll have the fenugreek seeds. Then by using the grinder and the sieve shaker, we could make the fine grain powder of the fenugreek. In the second picture, in the third picture, we use that powder, means that we could use our green inhibitor in drilling fluid. And in the last picture, we perform the different tests on the shale pallet. Okay, so I could conclude my presentation or the research here that the fenugreek is cost-effective inhibitor, and it moderate or it increase the rheological properties, filtration properties of the drilling fluid, as well as all the things lie within the API standard. So by performing different tests on different formation, we could use this officially in our industry. Thank you so much.
Assalamu alaikum, Dr. Muhammad Haris from UT Lahore. Okay, that's a very good work. First of all, I want to appreciate it. Did you perform this experiment on, mean to say, at high temperature and pressure? Because we are the drilling muds in the well depths. So what do you think that your results would be similar under high pressure and temperature conditions? What would be the impact? Will these inhibitors will sustain under high temperatures?
All right, so the first thing is I only performed this experiment on LPLT test. So I haven't performed this on HPHT, so I cannot predict the results as long as I perform it in our labs. So then I could say that all right, you could use it or you could not use it. But as long as I talk about the LPLT test, so you could use it. But as you talk about the high temperature and pressure, for that purpose, first we need to find out, perform this in our labs, then I could answer it. So thank you so much. That's all. All right.
So we just saw that you used about 1% and 2% of fenugreek, right?
Yes.
If you were to increase it up to 3% or 4% and amalgamate it with the drilling mud, do you think that the shale could become more hydrophobic and it could repel water at a more faster rate? Could that happen? Is there a chance that it won't turn toxic, the drilling mud?
All right, so that's a good question. The thing that you are saying it toxic, basically you asked two questions. First one is if we increase 3% or 4%. So we need to perform it whether the green inhibitor is increasing, is acting the same as it acting in 1%, 2%. So first we need to perform the experiment, then we could say anything. And the second one, you ask about the toxicity that you call the salinity. So that problem arises while we use potassium chloride in our mud. So while we use potassium chloride in our mud, it makes in a greater quantity, it makes our mud more toxic, more salinity, and this the first thing. And the second thing, it also breaks our drilling mud into two different phase, or you could say decomposes our drilling fluid. That's why we are moving towards the green inhibitor to sort out this problem. So hopefully green inhibitor would not do the same thing as the potassium chloride does.
Okay, thank you so much.
Thank you so much for asking. Thank you so much.
Now moving on to the last presentation for the evening, and the topic would be nanoparticles assisted polymer flooding in mature oil fields for enhanced oil recovery by Sagar Kumar.
Good evening everyone, Sagar Kumar here, final year student of Petroleum and Natural Gas Engineering, Mehran UET Jamshoro. I am honored to present my research finding in front of distinguished guest audience. So my presentation topic is nanoparticle assisted polymer flooding in mature oil fields for enhanced oil recovery. Could you please turn the slide? So these are the table of contents. Please turn the slide. After that, there is an introduction, and here is a brief introduction about my topic, that there are the many EOR techniques which are used for the edging fields, which are known as mature oil fields. But here the technique which I selected is nanoparticles polymer assisted technique, which is used to reduce the oil water interfacial tension and rock wettability. After that, it has a significant another advantage which is known as improve the oil efficiency, which is a major problem in the mature oil fields. After that, there is a small fraction of silica nanoparticles which is still not identified or analyzed at the microscopic level, and that's my objective, to identify and analyze the impact of nanoparticles and the micro-sized particles. After that, there is a problem statement. In mature oil fields, the declining production rates is a substantial problem, and the residual oil saturation within the reservoir present a significant challenge in the oil industry. As you know that the residual oil is the main problem in the mature oil fields, and conventional enhanced oil recovery techniques such as gas flooding or water flooding or another chemical floodings have certain limitations to enhance the efficiency, and they are not, the satisfied results are not got by using them. After that, we have used an innovative EOR method which is known as enhanced nanoparticle assisted polymer flooding, which shows the satisfied results. The objective of our study is, we actually have taken two scenarios. You can see in the figure 1, we have used water flooding, and the result of the water flooding is in front of you, that there is a not as such sweep efficiency by using water flooding. And the other end, we have used polymer assisted nanoparticles flooding, which has a satisfied result, as it has displaced a lot of the oil as compared to the water flooding. These are the objectives. After that, there is a scope of study that the feasibility and efficiency of nanoparticle assisted polymer flooding is especially analyzed for the mature oil fields, and also investigated that the nanoparticle selection is also an important parameter, and their interaction for the polymers and their impact on the oil recovery. Also, the environmental aspects are also analyzed. This is the scope of the study. After that, there is an important step which you can see is a methodology. In methodology, we have covered certain steps. First is the data acquisition. After that, two models were built. One is the water flooding, and other is the nanoparticle assisted polymer flooding. After that, their results are compared, and we come to an conclusion. A model was developed. Here is the data of the model. After that, there is a result and conclusion. Here, in modeling the model, we have taken 4 sport system for the injection. There were the 3 injection wells, and the 4th one was the producer well, along with their permeability and the other rock characters were analyzed here. Results here you can see, as our first model was the water flooding. So we flooded the water, and as you say, there was zero oil efficiency as the initial stage. As the water is injected, there was a gradual increase in oil recovery, oil production, and after the end of the 14 years, you can see there is a huge oil recovery, which is approximately about 488 meter cube. And after that, there is a water cut graph, which we observed that by using water flooding, there is another problem which was arising, that is the water flooding, water cut. Water cut is itself as a huge problem. So here in video you can see nanoparticle assisted polymer flooding which we used, and by which the oil efficiency you can see here in video. Here is another result by using nanoparticle assisted polymer flooding. In the graph you can see there is initially zero oil efficiency. After that, when we use, there is a gradual change in the oil production, just like after 6 years, after the 14 years, we have got a satisfied result as compared to water flooding. After that, there is also a water cut graph. You can say here, by using nanoparticle assisted polymer flooding, we have reduced the major problem, which is water cut that has been reduced here. After that, there is a conclusion. Nanoparticle has shown immense potential in oil recovery, also increased the oil efficiency, and the interaction between the nanoparticle and polymer alters fluid characteristics, enhancing oil efficiency. And the choice of nanoparticle and their concentration is also crucial in determining the success of the EOR method. Simulation has proved a valuable results by using this approach. And the overall finding of this research support that the potential of the nanoparticle assisted polymer flooding is a substantial and efficient method for enhancing oil recovery in mature oil fields, and promising results were get. That's all. Thank you very much.
Assalamu alaikum, Kushal X Miranian. So my question is that what is the key point of using nanoparticle for EOR?
Thank you for the question. There are the several key advantages for the using this technique, just like it alters the wettability, also increase the oil shape efficiency, and also it alters the rock properties such as viscosity. That's are the key advantages by using these techniques.
ये विस्कोसिटी को क्या करेगी, इंक्रीज डिक्रीज?
ये विस्कोसिटी को इंक्रीज करती है. दिस इंक्रीज इज एक्चुअली द विस्कोसिटी.
अच्छा, विस्कोसिटी जब इंक्रीज होगी तो हमारी प्रोडक्ट जो प्रोडक्शन है वो डिक्रीज होगी.
Amazing work, yeah. This was an amazing presentation. I may have missed the name of the nanoparticle. Could you tell me the name of the nanoparticle that you used?
Silica-based nanoparticle I have used.
Okay. Thank you so much.
Thank you very much for the question.
With this, we conclude our student presentations for the PE section. Now, I would like to call upon PE Student Committee Chairperson, Mr. Adil Sarati, to please come up and present a token of gratitude to our chair and co-chairs. Mr. Ijaz, please come on stage. Mr. Usman Dar. Let us begin with the student certificate distribution. For this, if Sir Ijaz, you would come on stage, please. Uzair Ali Rajpur. Dr. Asadullah Meman. Sundar Sham Jaswani. Junaid Ahmed. Ehsan Solangi. Faik Azhar Abbasi. So right now we are just calling the authors up on stage, and the certificates will be distributed to the co-authors later on. Abdul Samad CPO. He's not here? Okay. Any co-author here for the paper? Chale, okay. Mohammad Abdullah. Javeria Batul. Jawad Ali. Thank you, Sir Ijaz. Sir Usman, if you would please come on stage. Sadur Rahman. Mohammad Usman Khan. Fazal Hussain. Minhal Ali. Minahil is not here. Okay. Rida Siddiqui. And Sagar Kumar. I would like to thank SPE PAPG for arranging these sessions. I would also like to thank our chair and co-chair, our students, teachers, and universities for supporting the students to come up here. Everyone, a round of applause for each other.
We have a last year proceeding book for your libraries. So if someone come from UET, one from each university, UET Lahore first, you can give them. So you have to give it to your library. Last year proceeding. NED. दो बुक्स हैं दाऊद यूएसटी so this is booklet of last year for your library. Mehran University Jamshoro. Mehran University Khairpur. Anyone from BUTM? Daud? Anyone from Daud University? हो गया NFC. Anyone is here from NFC University? Multan? No? Anyhow, thank you so much for having this session. So the result will be announced in the closing ceremony.